Hey guys, in this video, we'll talk about trust algorithm. As usual, let's check the definition first. The definition of trust algorithm given by NIST white paper is trust algorithm is a process used by the policy engine to ultimately grant or deny access to a resource. Check this figure we used before. Trust algorithm is here. It's part of policy engine. So how policy engine here decides if it grants access to subject? This definition has already answered us, right? Policy engine use an algorithm to examine this subject. This algorithm is called trust algorithm. Trust algorithm is the core of policy engine. Policy engine is like the brain of zero trust architecture, and the trust algorithm is the way of this brain thinks. Like, should I grant this subject access to this resource? Yes, I should. Then because this subject has a property A or meets the requirement D. No, I shouldn't because this subject had property B but doesn't have property C. Yeah, a process like this. So this way of thinking is the so-called trust algorithm. And what kind of properties a subject are mainly checked? Is there a list of inspection standards? Actually, there is a list of inspection standards. NIST white paper has analyzed the common feature of subjects who might ask access permission based on what subjects can provide to the trust algorithm, to the policy engine, and other information possibly granted by the policy engine. All the information, all the inputs have been broken into 5 categories. So we can make a checklist to scan a subject and decide if it's safe enough and in compliance to grant access to it. Now we have a new problem. How should we evaluate this stuff? Now we know we should evaluate a subject from these aspects, right? But how? In fact, there are 2 ways to evaluate them. Before we dig into these 2 ways, let's first be clear with these 5 things we should evaluate. The first one, access request. Access request means the actual request from the subject. It's the information about the requester, which can include operating version and what software the requester is using, information like this. So how does it work then? Let's check this example. A resource like a website might require the user to use the latest Chrome browser because only Chrome is strong enough to show all their functionalities. If they found the access request is from an IE browser, they will deny it. Yeah, that's information could show up in access request. And the second one is subject database. It's a database that saves information of subjects. It's built for checking who this subject is. It's about user identities. User identity can include a mix of like logical identity, like account ID and the corresponding password, and the role of this account in the system, and privilege, etc. It's a collection of subjects' information, and this collection should be encoded and stored in an ID management system and policy database. Next one, access database. We said that access request basically is to check information like requester's device, software, and access database here is used to compare the observable status of the asset that subject is using to make the request. It can include the operating system version, software like pitch, and its integrity, all kinds of information about assets. Next one, resource requirements. Resource requirements are the enterprise's minimum requirements to access a certain resource. It could be a rule like only domestic IP allowed and deny access from overseas IP address. A requirement also could be like multiple factor authentication. A subject need to finish the multi-factor authentication to be granted access. Or it could be a requirement of asset configuration. So my understanding of resource requirements is it's a supplement to the first three rules, first three inputs. Those inputs are the information, and this one is the specific rules for them. The last one, threat intelligence. Threat intelligence is an information feed or feed about general threats and active malware operating on the internet. Threat intelligence could be external service or internal scan discoveries. Basically, any information that could help the trust algorithm detect attacks should be provided as threat intelligence. So now we know the main job of a trust algorithm is to evaluate the subject who passed access. A trust algorithm can rate the risk of network activity in real time and then make the decision. These 5 categories of information are inputs that trust algorithm needs to make the judgment. So these inputs could be gathered from subject, which is outside. Subject is the access requester, or it could be stored in database of the enterprise. And we say trust algorithm is a core component of policy engine, right? Which is a core component. Policy engine is a core component of zero trust architecture. So actually trust algorithm is a logical component of the zero trust architecture, and it's a necessary one. And the output of trust algorithm is always binary. Either say yes to the subject or say no. Okay, now we know what trust algorithm is, and now let's check how to design it. There are mainly two characteristics, two ways of thinking to differentiate trust algorithm. Both of them are to weigh the 5 factors differently according to the factors' perceived importance. The first is how the factors are evaluated. Now let's check the first way. The criteria-based algorithm allows or deny access. Now let's check the first way. Criteria-based or score-based. The criteria-based trust algorithm allows or denies access based on a set of criteria. A subject will be checked by this criteria one by one. It will be granted access if it meets all the requirements. The score-based trust algorithm uses a point system to grant access to the resource when the score is high enough to ensure high confidence that access should be authorized. All the inputs will be given a score. At how much every input weighs, depending on the enterprise and the organization themselves. If the score is greater than the configured threshold value for the resource, access is granted. Otherwise, the request is denied. Or the access are reduced, access privilege are reduced. Like sometimes we can get read access to a file, but not write access. The second perspective to design a trust algorithm is from the way of checking the request singularly or contextually. A single trust algorithm treats each request individually and does not take the subject's history into consideration when making its evaluation. This can allow faster evaluation, but there is a risk that an attack can go undetected if the subject stayed within or allowed role. And different from the singular trust algorithm, a contextual trust algorithm takes the subject or network agent's recent history into consideration when evaluating access request. Actually, the two factors are not always dependent on each other. Two ways of design can be combined together. It's possible to have a trust algorithm that assigns a confidence level to every subject and device and still consider every access request independently. And this white paper also thinks that a contextual score-based trust algorithm could be the best option to design a trust algorithm because it would provide the ability to offer more dynamic and granular access control, since the score provides a current confidence level for the requesting account and adapts to changing factors more quickly than static policy modified by human administrators. At the same time, contextual thinking can mitigate threats. So by this way, we combine contextual thinking and store-based thinking together. This could be the best option. So that's all content for trust algorithm. Thanks for watching. See you in the next one.